let's have a look at some features of measurement. Here I've got a plastic cap off an aerosol can, and let's imagine that I want to find the diameter of this cap. I've got a 30cm rule here, and I can use my 30cm rule to take a measurement of the diameter. And you can see I'm getting a measurement of 5.3 centimetres or 53 millimetres. There's a couple of features of this measurement I want to look at in more detail. And the first one is I'm expressing my result to the nearest millimetre, because that's the markings on the 30cm ruler. We call this the resolution of the ruler. So the resolution is the smallest interval that we can measure with this particular measuring equipment. Now the resolution of my 30cm rule is 1 millimetre. It might be that I'm happy with that if I'm just taking a rough measurement of the diameter of that to see if it goes in a holder or something like that. But it might be that I want a better resolution, a higher resolution. If I want a higher resolution measurement, I might use something like a vernier caliper. That will give me a higher resolution measurement. If I wanted a higher resolution measurement still, so for example, if I didn't want to measure the diameter of the cap, but I wanted to measure the thickness of the material that the cap was made of, I might use a micrometer screw gauge. You'll find out more about a micrometer screw gauge and a vernier caliper later on. But for now, let's go back to our meter rule measurements. So I'm quite happy with the way I measured that diameter. But let's imagine I'm not so good at using a ruler for measurements. There's a couple of things that could have gone wrong here. Have a look at this ruler and you'll notice that at the end there's a little section where there aren't any measurements marked. So my 0 point starts slightly in from the end. Now if I really carelessly didn't notice that and lined up the edge of my ruler instead of the 0 point at one end, I get an incorrect measurement. The measurement I read off would be too small. Let's imagine now that I go off and measure a whole load of other things. I'd have a whole series of measurements. They'd all be too small by the same amount, because I'd used my measuring equipment incorrectly. In this case, where we've got a lot of repeat measurements, and they're all incorrect by the same amount in the same direction, we call this a systematic error. And it's usually caused either by a setup error on the part of the person making the measurement, or by a calibration error, for example with a top pan balance that you didn't zero correctly. So a systematic error then, always incorrect by the same amount in the same direction. There's another kind of error that we could make though. Let's imagine that I was squeezing that cap slightly, and so when I took the measurement, some of the measurements I took were too big, and in a different orientation the measurement might be too small. Now maybe I was actually really conscientious, I realised something was going wrong and I took a lot of repeat readings. But these readings were sometimes too big and sometimes too small, and by different amounts. These kind of errors we call random errors. But actually repeating the readings was an excellent thing to do, because if I repeat my readings then I can reduce the effect of random error by taking a mean average of all of my results. And you can probably imagine just by looking at this that if I took a large series of measurements and took a mean average of all of those results, I would end up with a result that was very, very close to the true value. Of course, the other advantage of taking repeat readings is it allows us to spot anomalies. And if we have an anomaly appearing, we wouldn't include that in the mean average. So our main ideas here then are, we now know what the resolution of a piece of measuring equipment is, It's the smallest amount that that measuring equipment can measure. So the resolution of my 30 centimetre ruler is 1 millimetre. We know that errors can be systematic if they're always off by the same amount in the same direction, or they can be random if they're off by different amounts in different directions. And we know that to reduce random error, we can take repeat readings and average.